Hello, hello. I think we're live now. So welcome to this second session of Mobile Growth Summit. I'm super happy to introduce you to Denise Seligsohn. She's working at Google, APAC, and she will be talking about how machine learning and app measurement are changing the game for us app marketers. So I wouldn't go too far, and I will let Denise take over right now.
Thank you so much, Stefan. Good morning, everyone. I hope you all are well and, of course, staying healthy. As Stefan said, my name is Denise, and at Google, I lead commercialization strategy for app ad solutions for the APAC region. And I'm very excited to be here today to join you at the Mobile Growth Summit to share how machine learning and app measurement have become key pillars of the app advertising and marketing strategies. So with further ado, I will start and kick it off. So I'd like to start today by showing you these three images: a wireless headset, workout machines, and baby formula. At first sight, it looks like these three items have nothing in common, but actually the three of them are outcomes of space exploration inventions. So wireless headsets, the NASA built light hands-free communication systems that would allow astronauts to communicate with the teams back in Earth. And for workout machines, because extended exposure to zero gravity in the space was leading to bone loss or muscle atrophy, they needed to find a way to keep astronauts fit. So workout machines were invented for that. And last, NASA scientists were searching for a recycling agent to use during long space missions, which is now an additive in most baby formulas. So what I mean with this is that when something big happens, it happens actually everywhere. And the same is with machine learning. We associate machine learning to industry or business processes mostly, but it's actually present in a lot of our activities in our day-to-day. And for example, it's used in the transport industry. Ride-hailing companies, for example, use machine learning to plan routes and also, of course, to predict pricing. Apps like Google Maps also use machine learning to predict traffic and, of course, adjust also the routes. Facial recognition is another machine learning feature. A lot of us might have phones that unlock just by detecting our face, and this is thanks to machine learning. And the last one is one of my favorite things. I'm a Spanish living and working in Asia. So you can imagine that translation is something that I really need in my day-to-day life. This is actually a screenshot of my own phone. I was looking for machine learning in Spanish because I'm not used to talk about machine learning in Spanish, and I wanted to explain it to my family. So I started typing in machine learning, and before I could actually even finish, it already suggested me the term. So then this is the magic of machine learning. I already mentioned two apps or two Google products that use machine learning, but these are not unique for Google. At Google, machine learning has become central on how we think about product development. Almost all of our products have machine learning embedded in some sort of fashion. One of my other favorite apps is actually Photos. It uses machine learning to recognize people or items in your own pictures. But what is actually machine learning? I was looking for definitions before this presentation and found a variety of different definitions. The first one was saying machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. A second one, it's the study of computer algorithms that improve automatically through experience. And another one, machine learning is about teaching a computer to learn from data rather than rule-based programming. So actually, it comes back to two things. One, it's about learning from old data and finding patterns. And the second one, utilizing those learnings and patterns in new data. Let me explain how it works. You see in this picture at the left hand, a picture of a curled up dog in a laundry basket. How could a computer actually recognize that this is a dog? Rule-based programming would be trying to recognize the dog by looking at the legs, the ears, the tail. But in this form, it's a little bit difficult for the computer to actually recognize it. So what we do instead is we upload thousands of pictures of what we labeled a dog and thousands of pictures of what we would label as not dog. And we let the machine or the computer learn and learn from the signals and build patterns, and then try to recognize dogs based on these patterns. Every time it guesses it wrong, it adjusts and it gets better. So rather than building a set of rules, you're letting the computer learn and figure out things out by itself at the time that it would be actually recognizing a dog as good as a human being. We have here another example that I really love. It's about Quick Draw. Quick Draw, for those who are not familiar with, is a game that Google engineers built to show how machine learning works. It was released back in 2016. It's been a while, but I really love this game because it explains really easily how machine learning works. Basically, the user starts drawing an object and the computer would try to guess what the user is drawing as quickly as possible. The more user plays with it and the more users draw, the quicker the machine is gonna get and the better. I would have loved to play the game today with you, but instead what I'm gonna do is actually show you a quick video that explains how the game works.
Hi, I'm Jonas.
Hi, I'm Henry.
Quick Draw is a
game a few of us at Google made.
You draw and
the computer uses machine learning to guess what you're drawing.
I see square,
or suitcase,
or canoe.
Oh, I know. It's shoe.
It's an experiment that uses some of the same technology that translate recognize your handwriting.
To understand handwriting or drawings, you don't just look at what the person drew. You look at how they actually drew it. Which strokes did they make first? Which direction did they draw them in? You train the computer on millions of characters from hundreds of languages. And over time, it learns whether you wrote look or whether you wrote book.
Training is a big part of how the computer can guess your drawings correctly. As people, it's easy for us to look at these three drawings and know they're all cats. But to a computer, they're very different. One is just a head, one has a full body, and one is just facial features. To get the computer to understand, you have to show it a lot of cat doodles. And then it starts to see patterns, like that almost all doodles have cats, pointy ears, small nose, and whiskers. Of course, it doesn't always work. That's because it's only a few thousand doodles. But the more you play with it, the more it will learn, better it will get at guessing.
Oh, I know.
It's cat.
We put it on the web for anyone to play with. Hope it inspires other people to think about fun ways to use machine learning. You can play it at g.co/AI experiments.
So I would encourage you to actually play the game if you haven't, because it's a lot of fun. Of course, it would help you to understand how machine learning works. So we've been talking about what machine learning is and how it works. But the thing is that machine learning is not really new. It's been around for a long time. Actually, the first academic project that was using or applying machine learning is dated back to the 50s. For a gaming project. So the question is, why now? Why are we only starting to speak about machine learning and applying it to products in the last few years? The answer relies on two main things. The first one is technological development has brought us more computing power, which allows us to develop machine learning. And the last one, which I would like to focus today, is about data. We have access to a vast amount of data, which we use not to have it. I'd like to focus now from a digital and mobile perspective, what I mean by having access to a lot of data. We see this picture, and most of us are really familiar to it. Actually, most of us, I'm pretty sure that the first thing we do when we wake up, or if it's not the first, it would be one of the first things we do, is to go and grab the phone. And for some of us, even it would be the last thing we do before we go to bed. Our phones are now crucial for us, an integral part of our lives. We're always connected. And if that wasn't enough, phones are actually becoming even stronger and more robust. They're now sand resistant, water resistant, which means they're coming with us everywhere. To show you some impressive stats, based on the Ericsson Mobility Report from 2019, it states that there are 6.1 billion smartphones connected to the internet in 2020. Just to give you a little bit of the size of what it is, in the world, we are around 7.5 billion people. So that's an impressive amount of smartphones connected to the internet. From a usage perspective, we actually access our phones 74 times a day, and we spend around 4 hours per day in our mobiles per user. Actually, it's really impressive and also a little bit scary because it means we're a little bit addicted. But not only addicted, we are always connected, and that means we're generating data all the time. When we talk about apps, things are not different. Apps are actually an integral part of our lives too. We access a lot of services through apps. We play games, we watch videos, we communicate, but we also use it to book our rides, our travels, when we used to travel. And of course, we make a lot of purchases and shopping decisions. With the coronavirus outbreak, this engagement with apps has actually increased exponentially. In some markets, like in China, we've seen an increase of up to 30% more time spent on apps. The stats that I'm showing on the right hand are actually dated back from February. So I'm pretty sure in markets where the coronavirus outbreak came a little bit later, these numbers might be even higher right now. The reasons, of course, we spend more time at home and we are more connected with, and we use more our phones. But it's not only about usage and being more time in our homes. It is also we are accessing services that maybe we were accessing in person before. For example, we're now exercising using apps. We're meditating using apps, or accessing our banks and finance services. So now we know that for machine learning to be efficient, we need a lot of data. And now we learned also that as users, we generate a lot of data when it comes to apps and mobile usage. So connecting the dots, machine learning becomes key to help app marketers to manage this vast amount of data at scale, to also automate the data, and being able to adjust learnings and the new data in real time. So let me now explain how it works in a practical way for app marketing. When it comes to users, marketers know that not all app users are equal. Some users download apps and never open. Other users might be, for example, opening and purchasing once. And some other users, which is usually a very small segment of users, might be spending a high amount of revenue. Actually, less than 20% of users would generate more than 80% of the revenue for apps. So the question is, how do app marketers find these high-value users, these profitable users? Data analytics is actually key for marketers because it allows them to measure how users consume their products, how users discover their products. We collect data about our users to understand and know them better. And of course, we apply those data into our marketing campaigns. Before, we were using actually one-dimensional signals or a few signals when we were trying to analyze our users and optimize our campaigns. For example, we were looking at gender, at age, at location. And this made it relatively easy for marketers to actually optimize and create campaigns. But today, we move with what we call a multidimensional signals ecosystem. We have way more data now collected, and we understand way more about our users. We know now how many apps they have installed, how much they spend, how much time they're actually been spending watching, like a specific video, or for example, what device they're using. A lot of many signals that will help us to be more accurate and understand our users better. This is an ideal situation, actually. But I'm saying ideal because it actually presents also a challenge. We have a lot of access to a vast amount of data about our users, which should help us understand them better and being very accurate in planning and optimizing our campaigns or our marketing strategies. But it also becomes a big challenge for our marketers to make sense out of this data. Not only to make sense, but also it takes time for people, for workers and for people to actually dig into this data and get insights. A McKinsey & Company study said that 1/3 of the time spent in the workplace involves just collecting and processing data, time that we could be spending actually on maybe, strategic tasks. So now that we know that this is a challenge, I want to show you how machine learning actually helps app marketers from a Google perspective. Google App Campaigns is powered by machine learning. For those who are not familiar with, Google App Campaigns is our flagship product for app user acquisition. It enables marketers to find users across the multiple and primary inventories of Google, such as YouTube, display, search, or for example, Gmail or the display network. It is one single campaign type that enables marketers to find users just by uploading assets, budget, and of course, defining a business goal. Either you want to find, for example, users to download your app at a specific cost, you want to find users to perform a specific action, or you want to find users that should spend a specific amount of revenue in your apps. So once you define all of that, the beauty of App Campaigns is that it uses machine learning to analyze over 300 million of signals combinations in real time. It looks at signals from inside the app and outside the app. It looks, of course, first at those profitable users, at those users that are high value, and it would find patterns among them to apply them into the new data. So we would look to try to find users that are similar to the profitable users by looking at all these signals. It's not only about looking at those users, it is also applying machine learning to optimize. For example, it would be also trying to learn what message, what placement, and what asset actually works better, and then adjust and optimize in real time. So now that we learned that machine learning can help actually manage this data and help you find the users, I want to now go into the data analytics piece. As I said, analytics has been key for our marketers to understand users and gain insights. And it's needed to feed also the machine. If you go back to the examples that I was sharing before about the dog in the basket laundry, if I was to upload pictures of only cats, or if I was only to upload blurred pictures of dogs, it would be more difficult for the computer to start guessing and learn about how to recognize dogs. So it is also very important for marketers to have a strong and robust analytics tool and solution that is able to measure and collect as many signals as possible and integrate with machine learning to feed it back. In this sense, I'd like to introduce Google Analytics for Firebase. Google Analytics for Firebase is a full app analytics solution that provides unlimited reporting about analytics, and it provides insight of what happens inside the app and outside the app. The beauty of Google Analytics for Firebase is that by implementing the SDK, you get by default over 25 signals already installed. For example, you would get events like first open, purchase, or app update already by default without the need of coding or manual work. It also provides over 10 user properties that we can collect from the app. So all of those are signals that will be enhancing our campaigns. And we made it easy to integrate with Google App Campaigns. So what we do is by linking Google App Campaigns and Google Analytics, we feed the campaigns with the signals collected by Firebase. This is done following safe and transparent data controls, because we allow users to control their transparent data and their end-to-end safety. It also enables real-time and standardized data for machine learning. And what I mean by standardized data is that we use the same language. I always use this metaphor where I'm saying I'm Spanish, and if I would be doing this presentation in Spanish to a Spanish audience, maybe I would express myself quicker and faster, and audience would be getting the sense of what I'm saying actually also more quicker. So the same happens with this integration. Because of the standardization of data and that we talk the same language, we're able, the models, the machine learning of Google App Campaigns is able to get signals and understand faster and adapt them in a more efficient way. And through this integration, we also unlock new exclusive features based on optimization, audience segmentation, or, for example, bidding. Another great feature of machine learning and analytics in Firebase is Firebase Predictions. Firebase Predictions allows you to create user segments based on predicted behavior. So what we do is we take app analytics data and we apply machine learning to that to learn. And then we create user segments that are likely to spend or make an in-app purchase. Or we can also create a user segment which is likely to churn. Or last, we are even able to create a user segment which are gonna likely complete a specific event that we define. So this allows marketers to take product decisions rather than historic data on predicted and new data. So to recap, the success of marketing strategies relies on the combination of having a strong and powerful machine learning and, of course, data sources that feed those machine learning and computers. As I sometimes say in internal trainings at Google, is you can have a wonderful car, powerful motor, but if you don't have any fuel, it will be not as useful. So the same happens with app campaigns and analytics. You need to merge both and to have a very good integration among the two to get a successful campaign. So I've come to the end to the presentation. I really hope this session was of value to provide some highlight on how data actually enables us to understand better our users and should help us, to understand where to find them. And machine learning makes sense of it and turn those data into insights and actions. I think we have a little bit time for questions, right? Okay, if there are no other questions, I am happy to be contacted via my LinkedIn, which I believe is available. So, Stefan?
Hello.
Hello.
Yeah, can you hear me now?
Yes, I can hear you.
Okay, so I don't think we have like any questions from the audience. Maybe it's just the format; it's a little bit different for people, and they're not used to ask question online. So I have like myself one or two question maybe that can help the audience. I would have like a question about like, I mean, I hate being too technical, but I think it can still might be a little bit confusing for people to understand the difference between machine learning, business intelligence, AI. Is that a way for like an easy way for you to get the people to understand what is the difference?
Yes, actually, machine learning is an application of artificial intelligence. I mean, like, I can follow up if you want with a little bit of more detail, but I don't want to get too technical, honestly. But actually, one is a subset of the other one.
Okay, I just to make sure that the people can understand, because sometimes it can be a little bit like confusing for people. Just like, hey, data, then machine learning, BI, AI. Also, I think people can benefit a lot from machine learning using the tools offered by Google. And obviously, you need to access a lot of data, and you guys have a lot of data. Would you think it would be the same for anyone in the audience, knowing that do they need a massive amount of data to being able to use machine learning properly, or they would have like to use it through tools like the ones that you're offering?
I mean, it depends what we say with amount and what would be the use case. Of course, the more data, it will be more efficient. Like, as I said, you could, if you don't have enough data, and for example, I can bring it back to marketing strategies. When we recommend clients to set up app campaigns, we recommend that they need to feed the campaigns with events, or they need to look for events that happen at least 10 times a day. Because if we go for lower, events that are not happening enough, then the machine would not have enough sources. So it's not about working or not working. It will come down to the efficiency, how good it will become, etc. And of course, in this question that you're asking me, I would say it depends on what we're talking about, right? I mean, like, as I said at the beginning, machine learning can be applied in different industries and in different areas. I think already a lot of companies are using machine learning. As I said, ride-hailing companies is one of the biggest, or I would say the most clear example. Is there any other question?
I don't think there is any other questions besides saying like thank you very much for this amazing presentation. Obviously, it was very interesting to see how you guys are using offering and machine learning for the marketers and for all of us, helping us to provide the best marketing campaigns ever. So thank you very much. And I think if the audience has more questions, they have your contact and they have your link, so they can contact you directly.
Perfect. Thank you so much, Stefan, for having me. And I hope it was of high value.
It was. Thank you very much. Thank you for presenting.
Thanks. Bye-bye.
Bye.